last session of the Industrial Vision Days 2024. Happy to have you with us here live in Stuttgart, but also in the live stream. Welcome. Last session of the Industrial Vision Days is on embedded vision, so processor technologies and smart cameras. And I'm very happy to welcome the first speaker, Boris. Boris from... No, not Boris, Bruce.
Yeah, Bruce.
Sorry, what a long day. Bruce from the company neueste technology, and he's going to talk about elevating AI with GMSL cameras, insights into enhanced vision technologies. Okay. Bruce, the floor is yours.
Yeah, thank you. So I think I will have the remote controller of this one. It's here. Okay, thank you. Okay, so thanks everyone. I'm Bruce Pai. I'm a technical supervisor from neueste technology. So we actually are an embedded system industrial computer manufacturer, especially for the edge AI products. So today's topic will be why we can elevate edge AI with GMSL cameras. So I think this is a very, very high-level topic that will focus on the concept, so not so many technical things. Okay, so there's something really fresh I just heard. I just searched it on the internet news yesterday. So this is the very fresh Nobel Prize winners in physics, actually that win by a guy, a pioneer in in AI domain. So that's something that really shocked me because I was majoring in physics. So I think physics is really tough for me. Sometimes when you go into the fundamental physics, it's really tough, and so sometimes even boring. So I escape. I come to the software, industrial PC, AI domain. Then it comes to AI now. So even the physics now is something related to AI, or I would say AI related to physics. This is something that really surprising me. So this is just some interesting fact I want to share. So in a lot of time that we think there are two different things, sometimes actually there are one thing that's life is interesting, right? Okay, so back to the real topic. So when we thought about AI, I think when I was young, what will be the first one come out into my mind? I think most of you have seen this guy. The guy wear the laser jacket with his shotgun and shot everyone on his way. Okay. So, but now when we mention AI, I think the one who will come into mind will be this guy, Jensen Huang, a guy who wears laser jacket and uses his GPU as weapon to take down all the competitors on his way. So again, there's two things we thought is different, but actually the same: laser jacket and the weapon. Okay, so it's just something that really funny. Okay, for me. Okay, so back to the real topic today. So to know why the GMSL camera can help the edge AI, we need to know what is edge AI. So this is a wide definition, I would say. And what is the challenge to elevate the performance for the edge or the edge AI solutions or applications? And also, in the end, why GMSL can help on these edge AI applications? Okay, so we all know that the AI on the cloud, the most famous AI on the cloud solution, I think probably everyone knows, and it helps a lot in our daily life now, is ChatGPT, this big language model, generative AI, this all the buzzword of this year. So what's the difference when this is the AI on the cloud, so everything is centralized, it calculates everything, influence everything on the data center, on the cloud. So the difference, of course, about the edge AI is, compared to the AI on the cloud, is we try to separate the calculation. We put our brains, smaller computation units in the order of the age. So some examples, I think it's the most very close to the definition of the age AI, because actually you can think like, if it's a daily example, our cell phone could be, you can say it's an age AI thing, so, right? But we're talking about industrial solution, industrial application, something like this. Some robot system at the edge that can replace our human resource work. This will be, I would say, the most appropriate example of age AIs. So like this robot with arm and vision, and this kind of robot with wheel, moving robot platform with vision, sensors, even a drone system flying on the cloud, in the cloud, and in the sky, and have the sensors and vision cameras. So these are the very good examples of age AI. So we know that this kind of what kind of application is we need to think about it can be suitable for age AIs. So why we need the age AI rather than the AI on the cloud? I would say there are some very important features for that age AIs can benefit us. One is the real time. So when we are using the ChatGPT, I think most of you will have this kind of experience when you typing something, and it will doing something like thinking and inferencing and searching for the answer. So it takes like several seconds to minutes probably. So it's not real time. It's so slow. Sometimes because when it's taking a lot of calculation power to do the inference, but sometimes just because of internet latency. So sometimes even not reachable if you are offline. So that it's not real time. It's feeling the user experience is so bad. And sometimes this is if you think about all the AGI things which can move, you'll find that it will be very dangerous if you cannot put the AI at the edge. Okay, so this is the one very important reason. So the second one will be the flexibility, because when we can put all these AI small brains in different kind of machines, different kinds of locations, will be much more flexible. We don't need the internet infrastructure. We don't need anything connect to the internet. We can make it offline, and it can put it in a very dangerous place. So this will be very good, very flexible for the system deployment or for the application deployment. Okay, so the third one I just talked about is offline. When you can use it offline, it will be much different. Think about if you can use ChatGPT offline in your cell phone. You don't need you can use it on the plane when you don't have any Wi-Fi or 4G connections. Will be very useful. And one probably most important is nothing about technical. It's just a business model. So think about it, when you're using AI on the cloud, who will pay the bill? You have to pay the repeating bill to the cloud service provider, data center provider. But when you can put the AI everything on the edge, like our cell phone. So when the cell phone, the hardware manufacturer, Apple, Samsung, they sell you a cell phone, will say, okay, you have the AI, everything AI in the chip, so you have to pay for it. So this business model will make most of the client because it's a one-time bill, so it's more easier for them to pay. So this is also very important on the business side. Okay, so that's why we need AI at the edge. Okay, so when we're talking about the performance, because why the ChatGPT can have so good performance, so impressive performance, because it's something using a lot of computation power on the cloud, and the AI model is well trained. So the important thing is we need a very good computation unit for the AI, and also we need a very good AI models, well-trained AI models. So of course today we are in Vision Stuttgart, and all these examples, as you can see, all these robot things, one of the most important things that related to AI is the vision sensor, which is the camera, so which can represent like the human eye, a robot's eye. So this is very important, especially when it comes to the camera, when you need to influence what kind of a situation is going on surrounding you. You have a camera, so this is the most important sensor, I would say. So I will focus on that, and that's also why we will mention the GMSO camera today. Okay, so talking a little bit about how the AI models work. So we know that we call it neural network or deep learning or machine learning, whatever you want to call it. We know that for how the AI work is not like we have a very instinct question. We have a question and we can get a very straightforward answer. In a lot of time, the situation is more like this. It's like we make a wish to a parent here. We want to know the answer and wish it can give us the best answer. Yeah, so because sometimes if the AI is not so well trained, sometimes if your model is just not good enough, you will get the wrong answer. So it's very hard to get very useful AI. I mean, it needs time. So when you're developing an AI, it always when you want to make sure it reach the criteria, it always takes time and take a lot of effort. So to make it reliable and make it accurate. Okay, so this is the idea how to train a good AI model. It's always like you need to find a local minima in this kind of 3D map. This is just a concept, but anyway, to make it simple, you need to tune the model. You need more data. You need better data, and you need, of course, also about the algorithm you're using. But of course, you need the most important thing is the quality of the data, the diversity of the data source. So, which means better data quality is very important to AI. So that's why we need to talk about the image collection, the data collection, one of the most important things for the vision AI. Okay, so when we are collecting the data from the vision camera, we know that there are sometimes sometimes we use the compressed image, sometimes we use raw data. So this is just some research shows you that no matter you are using the compressed data or the raw data in different combination, it will have different result. So sometimes for different AI application, you need to use different kind of data. I mean, different kind of data resolution, for example, for training and for inference. So of course, you might say that why we can just use the best quality of data, the raw data. Usually will be better. Yeah, that's true. That's true. But sometimes it's not always possible because we need to think about the quality versus the quantity. So for example, if you want to take a video, I would say take a video of a 2 megapixel, using a 2 megapixel camera, the image size of one frame will be about 4 megabytes. And we say 13 frames per second, so you will have 120 megabytes per second. And for 60 seconds, you will have around 6 gigabytes. It's not possible to use all this data for training. It's incredibly big. So that's why. And also, if you have multi-sensors, if you have even higher resolution, 4 megapixel, 8 megapixel, it will make things not possible in your application, in your AI model. So come to GMSO camera. Why GMSO camera can benefit this from this point of view? Okay, so let's give a very quick review of GMSO camera. So GMSO camera is originated from the automotive industrial. So this just want to show you why this is very good at the edge, because it's somehow already proven solution for the edge, which the vehicle is probably the most I would say most safety concern edge device in the world. So it's a very ruggedized, proven solution. for the vision solutions. Okay, so the concept of GMSO is very simple. It's just extended from MIPI signal to the GMSO interface, then goes back to the MIPI signal when you put it into your computation unit. So it's very simple, very low, I would say, low-level technology. So which means it's low power consumption, low latency. It has this kind of benefit, and also it can provide very high bandwidth. So the very high bandwidth means you can take a lot of raw data by it. You can take a lot of high-quality raw data, high-quality images from the GMSO cameras. Okay, so also there are some common features of the GMSO camera which benefit to the on-road, automotive, industrial. I will not go through detail because this is also benefit for outdoor, in-vehicle features. It's not only GMSO camera have this, but a lot of GMSO camera have this kind of additional feature. So, but I will focus on the AI part today. So why the GMSO camera can benefit the AI at the edge? So I would say that the thing is about the flexibility. When we think about how the AI deployed at the edge, it's always like we have a well-trained model from the cloud, and we put it at the edge like this, and we do the inference, right? So this is some idea or classic deployment of the AI model at the edge. Okay, so sometimes we will need to make our AI model better by collecting the training data from this kind of edge AI devices. So with the GMSO camera, it can help you. It's possible because it's collecting raw data with a very high bandwidth. You collecting very high quality image, but you can also collecting some compressed image. So which means make it very flexible. You can no matter want to collect the raw image or the compressed image, it's all possible. Or you want to pre-process it at the edge. It's always possible with a good computation unit at the edge. So that's one very good example and why this kind of flexibility can help the edge AI. Okay, so think it big, a little bit bigger. We know that the HGX O-ring, which is the maximum performance of the O-ring generation of NVIDIA provides JSON platform, which is their embedded edge platform. Its AI performance is roughly around here. It's something between something under the RTX 6000 GPU, but the next generation of NVIDIA's JSON platform, which is Thor, it will be almost 10 times, have 10 times better AI performance compared to this generation. So, which means it can even outperform the RTX 6000. So, okay, so the thing is, when we think now this is HGX O-ring, it can use some edge AI model, you can use it as an inference, but in the future, you can use even bigger model, maybe the big language model, LLM model at the edge, and in the more farther future, maybe you can even have the whole data center's computation power into an edge device, which means you don't need to train your model on the cloud. You can train it at the device. So it makes this kind of flexibility when you are deploying your system. You have a very flexible image acquired system that can make your edge device very useful when it comes to the future. Of course, this is just something that we think that probably will happen. Okay, so with this kind of design, this could be the future, I think. So I think the edge AI device can be getting more important in the future because of course, will have even better computation power compared to today, and it probably can self-train itself, improving its AI model. So it's not only benefit to the performance. We know that we are also care about the cybersecurity things, the privacy things. That's very important because when you can keep all the data at the edge and you can train everything at the edge device, this will not be a very hard to deal with issue in the future. Okay, so this is something that I think this kind of GMSO camera can benefit to the edge device because its flexibility about no matter the image quality or the capability it can provide. Okay, so this is just sum up, just talking about something we mentioned in the slide, and of course in the end, let me show my companies. This is my KPI. So we Neosys provide a lot of industrial PC in different domains, and we also have a lot of GMSO camera support platform, as you can see here from sort of the JSON. Of the JSON platform. So please contact us if you have any question, and we are at D14 at this hall, so you can check with us if you have any more questions. Also, you can scan the QR code to contact with us. Thank you.
Thank you, Bruce, from Neosys.
Yeah.
Great. I would like to welcome my next speaker, Harald Werner from Efinix.
Yep.
And you're going to talk about elevating AI with vision optimized FPGAs. It's a long day.
Yeah.
Vision optimized FPGAs for intelligent edge camera applications. Harald, looking forward to it.
Thanks a lot for the introduction. Hi. So you heard a lot of edge AI, you heard a lot of cameras. Now we're going a bit deeper into a camera. What do you need to put behind the sensor to do some image processing and all this stuff? And this is where you usually can use FPGAs. What is the benefit using FPGAs compared to microprocessor? An FPGA can do things always in parallel, where a microprocessor can do only step by step everything in series. And therefore, FPGAs are very common in these camera applications. Some words about Efinix. So we are an American-based company, and we have our headquarters in Cupertino, just around the Apple Circle. We have development locations in Toronto, Penang, and our headquarters here in EMEA is in the north of Munich, and we have as well an application office in Manchester. This is important because you have to make sure that you get the support you need if you develop an FPGA. FPGA companies are around here since more than 40 years. But as well, they are using the same architecture since 40 years. If you look at the right-hand side, or left-hand side from your side, they usually have fixed logic blocks, fixed routing. Especially routing is important in an FPGA because you do not know where your design is placed on an FPGA, and therefore you have to provide a lot of routing to your FPGA that you guarantee a connection from A to B. This ends up in a very large die because you need this high amount of routing. We solved this problem in our quantum architecture. What is the difference? We have our cells, our exchangeable logic and routing cells, which can handle both logic and routing. Means with our architecture, we can provide routing in the area where it is required. So we have not to have all these huge routing resources in our chip because we can place a routing where we need it, and our cells can do both logic and routing, and both as well at the same time. And this will end up in half of the die size to a comparable device from maybe the market leader, and as well lower power in dynamic, but as well static power. And this is cost optimized because at the end you have a die size, and this is usually the base of a cost of a device. And very important is that we are silicon process agnostic. Why is this important? I think we all remember 2-3 years ago, we all had these problems to get silicon devices. And at this time, with our architecture, we were able to deliver the goods to our customer with less than 20 weeks lead time, because we did not have special requirements on the silicon process. So we are taking the process parameters from the process manufacturer, putting it to our FPGAs, and done. And then they can put our lot into a high-running scheme without interrupting the performance in this. And therefore, we were always able to deliver our goods as well in the rough time. What are our FPGA families which you can use for connecting the sensors to the FPGA, but as well putting your output out from the FPGA? We have the Trion FPGAs, which is based on a 40 nanometer SRAM process. And so it's a standard FPGA, mainstream FPGA, which can be used everywhere. But important for the camera application is even this FPGA can handle 1.5 gigabit MIPI interface, which is important for the sensors. Then our Titanium family is based on a 60 nanometer process. And this guy can handle up to 2.5 gigabit per second on a MIPI interface for MIPI CSI and DSI. And we implemented a low-power DDR4X memory controller that you can store as well your frames if you would like to manipulate them or you check them out. And we added as well high-speed SerDes to the FPGA that you are able to handle on your camera 10 gigabit Ethernet. You can handle PCI Express, you can handle Co-Express, CP12, or all these high-speed interfaces which are required for the camera applications. As not everybody needs 16 gigabit SerDes, we have as well a more cost-optimized version, the Topaz family. This goes up with a SerDes speed up to 12.5 gigabit, which is still good enough for our 10 gigabit Ethernet camera, and as well supporting you with low-power DDR4 memory controller and the MIPI interface up to 2 gigabit per second. All the families can be designed with our Affinity tool, which is free of charge. Means you can register on our web page and you have access directly to our software. Here an overview, especially for camera or vision applications, because what you are looking for, MIPI interface, what is the speed, so depending on your sensor. Here an overview, what is Trion providing you, what is Topaz providing you, and Titanium. Important as well, the memory interfaces, and we choose LPDDR4 or LPDDR4X, because this gives you as well the power benefit, which is usually required in a camera application. For computing, if you need some microcontroller inside, we are focusing on RISC-V-based processors. So that means we are supporting RISC-V processor in all our family on a soft IP core base. So in Trion, it runs up to 120 megahertz. In Topaz, up to 250. In Titanium, up to 350 megahertz. Still a soft processor. In Titanium and Topaz, we added as well to the devices which are supporting high-speed SerDes and hardwired quad RISC-V core, which is able to run at 1 gigahertz. And this is good enough for a lot of applications. But the big benefit for you is, so we did some measurements. We had running a core with 4 cores at 1 gigahertz, and we are roughly consumed 500 milliwatt. And if you compare this to other applications, this is a big benefit. And power consumption or the related heat you are generating in a camera, it's not necessarily a friend of you. An additional application we have here for special cameras is our TI-60 F400. We are calling it a SIP, System in Package. What have we done? We added to a 60,000 logic element FPGA a HyperRAM module, with up to 256 megabit on memory, and we added a SPI flash into the same package. Means now you have a package 5.5 by 5.5 millimeter, which contains a 60,000 logic element FPGA, the related SPI boot flash to it, and a 256 megabit HyperRAM, which you can use maybe for your processor or store a frame from your camera in this application. All the standard high-speed IOs are able to handle 1.5 gigabit MIPI, and we are supporting as well MIPI by 8 if you need a wider MIPI interface. What is the benefit of using Efinix in your FPGA or in your camera design? I think what we are focusing is really to focus on the customer, not necessarily on the money, because we are still a private company and not a public company. Therefore, we have the benefit to set our goals and therefore try it out. Always the feedback we get from our customer that the support is really outstanding. And because of our architecture we have, the quantum architecture, we are able to do really small die sizes in our FPGAs. For example, a package 3.5 by 3.4 millimeter with 60,000 logic elements. Try to find this somewhere else. And in the same time, if you have such a small die, you must be able to have low power, because otherwise you will not get the heat out of the system. And then the package I already mentioned, the 5.5 by 5.5 millimeter as a system in package. This is as well only possible if you have small die sizes and a low power consumption. Otherwise, the package would burn out because you have additional power consumption from SPI flash, from HyperRAM, and then the additional 60,000 logic elements. Our FPGA is supporting LVDS interface you need usually for the sensor interfaces. MIPI always depends which you are using. We are supporting as well SLVS EC interfaces for the higher end sensors, and USB 3 with the different FX solutions from Infineon. Ethernet 1 to 10 gigabit, not a big deal, and PCI Express up to Gen 4. So usually everything you need for your camera design, or as well frame grabber. Important as well, especially for our customer, is that we are delivering our software free of charge. So you do not have to pay something. You do not have to request a license. So you are registered on our webpage and you have access to our software, install it, and it's working. And everything is proven in use. Check around here some camera vendors. Very often you will find Efinix as their FPGA solution. Even go to the Infineon booth for all this FX10, FX20 stuff. You will find our devices which they chosen as their eval platform. I mentioned already that we are focusing on RISC-V as our soft IP, RISC-V as well hard IP. So we are offering here Sapphire SoC. This is our standard RISC-V soft IP, which goes up to 350, 400 megahertz. So must be a marketing fault with a 400, more 350. And even on this soft IP core, you are able to run Linux on it, because we are supporting as well an MMU and an FPU for this kind of processor. If you say, RISC-V is nice, but I do not need such a big system, we are supporting as well a Sapphire Lite. Just if you need a controller which is putting some register here, some information there, then we are offering you a 4K logic element soft processor, RISC-V based. And then our high-end, the Sapphire high performance SoC. And this is in all our FPGAs which has high-speed SerDes included. So with this, we have a quad RISC-V implemented, which runs up to 1 gigahertz. And not important the speed, but the speed and the power. So we are in the 500 milliwatt area if the 4 cores are running at 1 gigahertz. And this is really outstanding in the market. Usually you need additional IP cores for your FPGA generation. And therefore we have our IP manager where you can find all the other IP cores which are required from some memory stuff, FIFO or block RAMs. We have the whole MIPI interfaces there. We have a triple Ethernet max spec. And now I think with the next version which coming out end of the month, we're adding a 10 gigabit Ethernet MAC to it. All the cores you can select, specify the core, and it gets generated. And all the cores you will see here belonging to the software. As the software is free, the cores are free as well. To do a proof of concept of your product, you can use as well development kits. Here a list of development kits for our Trion family, for our Titanium family. Our latest board which is available is a TI-375, so it's a titanium with 375,000 logic elements and has 16 gigabit SerDes channels. And this board provides you a PCI Express finger with PCI Express Gen 4x4. We have this SFP Plus cage for 10 gigabit Ethernet and FMC connectors where you have access of additional 8 high-speed SerDes channels and user IOs. And on the right-hand side, the QSE connectors. Here you can connect our MIPI interfaces up to 2.5 gigabit to it. Here's an example which we are showing at our booth is our TI-180 connected to a MIPI camera with 4 times 2.5 gigabit per second, and then connecting via USB 3 10 gigabit to the PC and then showing the picture on the monitor. And if you would like to see the first industrial camera which are handling this, you can go to IDS Imaging. They already have an industrial camera where they are using our titanium in combination with the FX10. Software, I told you already, the software is free of charge. Just go to our web page, to the support page, register, and then you have access to our software. We have a netlist viewer if you would like to see a schematical view of your VHDL, System Verilog or Verilog. On VHDL side, we are supporting VHDL 2008 and VHDL 2019 interface. So really the state-of-the-art standard of VHDL. Then sure, we have a floor plan viewer, interface designer. This is a bit different approach to standard, to the other FPGA vendors. All our IP cores we are providing are in the interface designer. So if you have a PLL, you would like to generate 3 clocks, you are generating the 3 clocks in the interface designer, clock 1, 2, 3, and then the connection is done in the entity top module, clock 1, 2, 3. Done. But then you have all your design in the core design, and all what is vendor specific for Efinix is in the interface designer. Then you have as well access to our SerDes in the interface designer. Just click on the PCI Express or Gigabit Ethernet, and then you can configure all the stuff. And the interface to your core design is an AXI bus. So you do not see all this IP cores which has to be instantiated for PCI Express. You just see the AXI bus, and the configuration is done in the interface designer. Package view as usual, and a hardware debugger. So we have not these fancy names as all the others. We are just calling a debugger. You can automatically instantiate this debugger in your design. You can add some trigger points to some signals. If the trigger point is reached, then we are generating a VCD file, and you can see all the internal signals from your design. We have as well a debugger for the SerDes channels, and you can see on the RX side which signals are received without having a very expensive scope, but sure, you can use it as well to do the electrical check. If you do some safety applications as well, the software we have certified. And we are running on Linux and Microsoft Windows. Thanks a lot. Do you have questions?
Thank you, Harald, from FNX. Questions, please talk to Harald directly.
Yeah.
Because time is running, and I would like to say a very warm welcome to my last speaker of Industrial Vision Days 2024.
Patrick.
Patrick.
Yeah.
Patrick, the other Patrick, isn't
Yeah,
it?
yeah, that's correct. Thank you very much.
The other Patrick. So Patrick from Wengler Sensory Group, and you are talking about modular software as an entry point into industrial image processing.
Yes.
Patrick, the floor is yours.
Yeah, thank you very much. So, Harald, thank you very much for this deep dive into technology. It was impressive. I would like to invite you all now to let's go a little bit up into a higher level of machine vision and look at the start where all our customers have to begin to work with our tools. So modular software is an entry point to industrial image processing. We would like to look at current trends and challenges in automation, modular machine vision for parameterization, the limits of the parameterization, and where we can exceed the limits of parameterization. So, who are we? Wengler is a medium-sized company from the Lake of Constance. We have 3 production facilities in Europe. We are present all over the world in 16 countries with direct offices, and we're happy to serve you wherever you are. But what do we serve? Now, you can find in our portfolio machine vision software, 2D, 3D profile sensors for measurements, robot interfaces, and machine vision for inspection systems. The target, or why we actually do that, is because we have to follow the trends in automation, and we have to find answers to the challenges of companies trying to implement more automation and overcome the current limitations that they face in daily business. Now, the skilled labor shortage is one issue that I can hear from all over the world. I travel a lot in Asia. Even there, they have a lack of qualified workers to make sure that the production works fine. The customers are getting more demanding by demanding zero defect production, or at least delivery. The big data integration to manage the overall company well is posing additional demands on the overall data generation, and better human-robot collaboration to have more efficient production environments is also a big issue. Now, how can we answer these questions? And from our point of view, we see that in the machine vision can address most of these challenges in different ways. So a visual quality inspection can help us to make sure that the products are made according to specs. A proper setup machine vision system can ensure that there is a zero defect production, or that we can detect any defect before it actually affects our delivery. To feed the big data integration, you need sources of data where machine vision with imaging and measurement can provide all the necessary information which can run into a MEMS system to control the overall production flow. The cobot world requires also cameras to make sure that the human and robot collaboration works without that anybody gets hurt. Here we can provide the eyes that your robots can act without interacting too much. Now, when you start to implement machine vision into your systems, you have to interact with our cameras. You have to tell the vision software what information you want. You have to adjust the camera, and you have to set up everything in the proper way. And the easiest way to get started is with parameterization. And parameterization will enable most people to have a steep learning curve and to create solutions that would be very difficult with the conventional solutions out on the market. So our aim is to lower the entry barriers that enable more people to actually work with our tools. We strive to make the tools flexible and scalable so that our customers can work with a very easy start and develop more complex scenarios over time as they learn more about machine vision and as they understand what the production actually needs to run better. The last step, we want to make sure that the customers are ready to solve complex applications, and for that there are multiple ways on how we can achieve that. The classical way is that you take the imaging device and connect it to a PC where you run a complex software, but that is a jump. Few companies can make that easily, and with parameterization we can reach sometimes our limits. Now, they may be the advanced imaging tasks where the tools available are not sufficient. It can be handling complex workflows where you may want to make shape from shading, and an advanced error handling and debugging required, for example, by the new okay, just a second. Required by company policies, for example. And the solution to that can be that you have access to a parameterizable software which also has a module block where you can code inside. And this is where the Univision is offering you this exact module where Halcon can be used to script inside the Univision, inside a parameterizable software, which is very easy to use, and then you can have one specialist inside or outside the company who is actually able to script, to code, to create custom complex vision solutions, put that inside an easy to use software, and the whole things become very, very manageable. You can also use the all the infrastructure that the parameterized software is already offering, like image acquisition, camera parameterization, and all the output channels like gigabit Ethernet or Ethernet IP ready to go, so you have less hassle in programming these interfaces. Let's already jump to the conclusion. It was a fast and efficient presentation here. Automation can propose challenges to companies if they are using too complex tools. Machine vision can address many challenges in automation, but again, you have to use the right tools to make it manageable. Machine vision systems with the parameterization software allow for an easy integration with low entry barriers, and if you have reached the limits of parameterization, please don't hesitate to use the possibilities you get with programming. We are welcome to check out our Univision 3, the solution that can manage both worlds. Thank you very much.
Thank you, Patrick.
It was my pleasure.
Last speaker of Industrial Vision Days
It was my
2024.
honor to fill this slot.
Perfect. Well done. So, Industrial Vision Days 2024 come to an end with Patrick's presentation. If you have missed some presentations that are looking exciting, that you thought like, oh, I would have loved to hear that talk. If you would like to hear Patrick's talk again, all the speeches, all the sessions are available in the stream, in the live stream, but also on demand starting tomorrow. So grab the opportunity now to ask Patrick to go to the Wenglor Sensoric booth over there for the rest of the 10 minutes of today.
Yes, you're very welcome.
And make use of the Industrial Vision Days online. And yeah, I say thank you for staying with us and have a safe trip back home. And looking forward to seeing you at Vision 2026.
Thank you very much. We will be there.